Previous segment we showed how electrical charges could be separated through mechanical means. So by this belt that was going around and it was rubbing up against something, and that was physically pulling off the electrons. We can also separate electrical charges without physically touching them. And so this is going to be separation of electrical charge by polarization. And in this picture here, it shows a charged rod. So this is a negatively charged rod. Okay, you're going to bring it up to a very small piece of paper. All right, so normally the kind of paper that you would use for this experiment would be the kind of paper that comes out of a hole puncher. So things that are teeny tiny. Now it doesn't have to come out of a hole puncher. You can just take a regular piece of paper and tear it up into teeny tiny little pieces. But you're going to take a rubber rod and then rub it with paper or something so that it becomes negatively charged. And then you're going to hold it up against, or no, don't touch it, but bring it close to one of those little pieces of paper, and then you should notice that the piece of paper is going to be attracted to that rod. Okay, so how is this possible? So here is a magnified view of a piece of paper. And now this piece of paper is going to have atoms in it. And then each one of those atoms is going to have a nucleus, and it's going to have electrons in orbit around it. So this is electrically neutral. For every electron, there's a proton to go with it. So this thing has a net electrical charge of 0. But as you bring this negative charge closer and closer to the piece of paper, positive charge would be attracted to negative charge. So the nucleuses of these atoms are going to move ever so slightly towards this rod. So the positive charges are going to be attracted to it, and the negative charges are going to be repulsed by it. So inside of every one of these little atoms, you're going to have a separation of charge. What did we call that? A electric dipole. So this was an electric dipole, and so that's occurring in each of these atoms. Now the next thing you want to consider is look at the distances here. Look at the distance between the negative and the positive, and then look at the distance between the negative and the negative. There is a slight difference in the distance. Do you remember Coulomb's law? So Coulomb's law said that the force of electricity was proportional to 1 over r squared, so that as the distance gets smaller, the force gets bigger. If the distance is bigger, the force gets smaller. So that means that there is a slightly greater force on the positive charge than there is on the negative charge. And so when you add all of these atoms together, then you get enough of a force that will attract the piece of paper to the charged rod. The same thing will happen with a piece of metal, like a little teeny tiny piece of aluminum foil. You can do the same experiment, but the difference this time is that the electrons, instead of just separating a slight difference because they're trapped inside of each atom, the electrons can travel through the piece of aluminum foil, and they are on the opposite side over here. But it's the same general thing, that you're going to have two different distances: the distance to the positive side of the aluminum foil and the distance to the negative side. So I got this little video here that I want you to watch. Attraction of metal and paper to a charged object, relative strength comparison on YouTube. So go ahead and watch that, and I think you'll find it interesting. Okay, another example of charge separation is called the gold leaf electroscope. And a gold leaf electroscope is going to consist of a conductor, and then it's got a conductor that goes down like this, and then attached to the bottom of it is going to be two gold leaf, two pieces of gold leaf. And so normally they hang down like this, so that normally the gold leaf electroscope is going to be electrically neutral. Now, what would happen if we're going to take a positive rod and we're going to bring it close to this neutral thing? So this has both positive and negative charges in it, equal numbers of positive and negative charges. So what will happen is negative charges will flow to the top up here because they're being attracted to the positive rod, and then by conservation of electric charge, if the positive ones are up here, or the negatives are up here, where's the positives? They're going to be down here. And so positives are going to start to appear on the leaves. So let me go ahead, if we've got 4 of them on the top, we need to have 4 of them on the bottom. So 4 positive charges, but remember, what do positive charges do to each other? They repel. So the 2 leaves are going to move apart like this. So I'd like for you to watch this gold leaf electroscope experiment on YouTube. Okay, notice what happened if you took the charged rod and you touched it to the gold leaf. So you take your rod, you bring it close to the gold leaf electroscope, and the leaves open up. Okay, but then if you take the rod away, the leaves go back to the way that they were. But did you notice what happened if he touched the rod to the gold leaf electroscope? Then he transferred charge to it, and now this thing now has net electrical charge, and the leaves are going to stay open. Did you notice what happened when he touched it with his finger? So when you touch the gold leaf electroscope with your finger, you ground it. You provide a path for the electrons to go through your arm, down your leg, into the floor, and so it drains the gold leaf electroscope, and so the leaves, they go back to where they were before. So for the exam, be able to explain how a gold leaf electroscope works. What do you think would happen if this was a negatively charged rod? Same thing. The only difference is that these would be positives up here, and then down at the bottom it would be negatives. So it works either way, with a positively charged or a negatively charged rod. All right, let's take one more break, and when we come back, we're going to talk about electromagnetic shielding.